Welcome to MrCScience.com's video on the 3 basic types of reactions. In your book, they talk about 3 basic chemical reactions. In reality, there are a number more, but we're just going to start with these 3. They are decomposition, formation, and combustion. Let's talk about each one individually. The first one is decomposition. Your book talks about the decomposition of water, H2O, as a liquid. It is basically they take salt water and they place a battery inside of it, and they get bubbles off each terminal. They use test tubes to collect the gases, and we found that when we decompose water using electricity or electrolysis, we get hydrogen gas and oxygen gas. Okay, this one isn't balanced. We got 2 hydrogens, 1 oxygen, 2 oxygens, so we need to double this. So now we got 2 oxygens, but now we got 4 hydrogens and 2 hydrogens, so we need to double that one to get to 4, and now it's balanced. This is a decomposition of water, so it breaks it down into its elemental forms. H2 and O2, both hydrogen and oxygen are homonuclear diatomics, which you'll remember, so they always form 2s. Let's take a look at something slightly similar. Let's take a look at the decomposition of hydrogen peroxide, H2O2. It also is a liquid at standard room temperature and pressure. When you hydrogen peroxide will naturally break down into water and oxygen gas. So water will be a liquid since there isn't any heat involved. If you have a bottle of hydrogen peroxide in your bathroom cabinet, you'll notice that if you pick it up, it's been there a while, it'll feel kind of ballooned out. It'll be under pressure. That's because this oxygen, oops, I forgot the 2, O2, gas takes up more space and it'll pressurize. So this is not balanced. We got 2 hydrogens, but we got 2 oxygens and 3 oxygens on this side. So first thing, we got an even number here, so we got our odd man out. Let's double that, and that'll give us 4 hydrogens, or 4 oxygens. So we need double that here, so 4 there, and then we already doubled the hydrogen twice, 4 and 4, so everything's balanced here. So this is a decomposition reaction that does not go completely to elemental levels. So you get O2 gas, but then you get a molecule of water off it as well. So decomposition can go all the way to elemental level, or decomposition can just break it down into component parts. One way you'll be able to tell a decomposition reaction for sure on your study guides and tests is it'll always start with 1 molecule and break it down into 2 or more elemental or molecular components. Okay, the next one is formation reactions. Formation reactions are really just the opposite of what we have here. 2 or more elemental components will form up to make 1 molecule. So we're going to do the opposite. If we start with hydrogen gas, and we burn it in the presence of oxygen gas, we will get water as a gas, water vapor, because of the heat involved. So again, balancing it, 2 hydrogens, 2 hydrogens, 2 oxygens, 1 oxygen. So we're going to double our oxygens here, which means 2 oxygens, but 4 hydrogens, 2 hydrogens. We're going to have to double our hydrogens here. Now we're balanced. This is a formation reaction. Again, just the opposite of your decomposition reaction. Let's use a different one, going back to biology. We know that plants take carbon, Control Z is your friend. Carbon dioxide gas plus water, usually a liquid taken up through there, and they make sugar out of it. Oops, my mistake. Let's back up a little bit. They can take carbon dioxide, water, yep, that's right, water, which is a liquid, and they make sugar out of it. Now, while this is a formation reaction that won't appear in your book because what actually happens here, sugar is a solid. What actually happens here is you've got some leftover oxygen that it gives off as well. So you won't see this formation reaction in your book because your book will only go to 2 molecules, but here we're taking some smaller and making a larger molecule. So let's go ahead and balance this equation. We got 6 carbons. We only got 1 carbon. We're going to put a 6 here. We got 12 hydrogens. We got 2 here. We need a 6 here. We've got 8 oxygens here. We've got 6 plus another 12 is 18. So we're going to need 10 more. So if we do a 6 here, that's going to give us 12 plus 6 is 8, 18. So now we're balanced. So this in reality is a formation reaction again. Again, your book will not have this because it's got this extra little oxygen hanging off here. But in reality, that is a formation reaction. The final reaction is combustion. Combustion reaction is actually taking usually a hydrocarbon. Here we're going to start with methane, CH4. We're going to add oxygen and energy, so we're going to burn it effectively. And whenever you burn something, you get, especially like hydrocarbons with nothing else in it, you get carbon dioxide and water. This is a gas. This is a gas. This is a gas. And this is a gas because of the energy you produce steam. So burning something is generally adding oxygen to it and getting carbon dioxide and water. Let's balance this. 1 carbon, 1 carbon, that's fine. 4 hydrogens, 2 hydrogens, let's double our hydrogens. 2 oxygens to 4 oxygens, we need to double our oxygens here, and we are balanced. So this is combustion, and actually this is called complete combustion. So if that's complete combustion, what is incomplete combustion? Well, incomplete combustion is where you don't have quite enough oxygen. If you don't have enough oxygen, we're not going to balance this because you get a little more complex than we have here. But if we take methane and oxygen, both of them are gases, but we have not enough oxygen, what'll happen is it'll short an oxygen on the carbon dioxide, and we'll get carbon monoxide. Same elements, different compositions, very different from each other. Both are gases, clear, colorless, odorless gases, but this one is non-lethal. This one will cause you major problems, so you can get what's called carbon monoxide poisoning. If you go even further and you reduce the oxygen even further, we still got O2 gas, but not near enough. Then you will get just carbon and water vapor. And so this will be basically soot. Carbon based, that's how they make charcoal. They burn wood generally in a low oxygen atmosphere. It leaves carbon behind so that you can burn that carbon, you can combine it with oxygen and make carbon dioxide and a little bit of water vapor if there's any hydrogen around. So that is combustion. Combustion is adding oxygen to generally a hydrocarbon, getting carbon dioxide and water. This is complete combustion where you just get carbon dioxide. Incomplete combustion, you get either carbon monoxide or carbon, just elemental carbon. If you have any questions on this, feel free to drop me a line at mrcscience.com. Thank you.